Hello friends, this video on Communication Systems Part 13 is brought to you by examfear.com. No more fear from exam. Okay, so let us first start with amplitude modulation. So let us now see how exactly amplitude modulation will happen in case of a sinusoidal wave. Okay, so by now we know that what all do we need for an amplitude modulation? We need a carrier wave. So let us take a carrier wave. So what kind of wave is a carrier wave here? It is a sinusoidal wave, and carrier wave is a high frequency wave. So the carrier wave is going to be a high frequency sinusoidal wave. Right? So let us suppose we draw it like this. So let us suppose this is a carrier wave which we have. What else do we need? We need a message signal. Like there has to be a signal, right? Only then we talk about modulation. So we need a message signal. So this message signal is a low frequency wave. So maybe it is somewhat like this. So this is high frequency and this is low frequency. So what is the amplitude of this wave? This denotes the amplitude of this wave. Let us denote the amplitude of carrier wave as AC. So what will be this? This will be minus AC. Similarly, what would be the amplitude of this message signal? This. So let me denote it as AM. And this will be minus AM. Right? So now we have a carrier wave and we have a message signal. Now what is amplitude modulation? When I talk about amplitude modulation, that means the amplitude of the carrier wave will get modulated. So that means there will be no change to this wave. This is the carrier wave. So this wave's amplitude will get modulated, but the frequency will remain the same. So what denotes frequency? How close these waves are with each other. That denotes the frequency, right? So that will remain the same, but the amplitude will vary. Now how the amplitude will vary? The amplitude will vary as per this message signal. So it would be somewhat like this after modulation. Now, what was the amplitude before? What was the amplitude of the carrier wave? AC. So this AC was the amplitude of the carrier wave before modulation. But now this amplitude will get changed. How it will change? As per the modulated wave. Now, how is the modulated wave? The modulated wave is somewhat like this, right? So similarly, so if this is AC, this distance becomes AM, that is the amplitude of the message signal, right? So this is how the amplitude will change. The amplitude will change as per the message signal. So the similar change will take place this side as well. So this is how the amplitude will be of the new wave which is formed after amplitude modulation. Now the question is, what about the frequency? The frequency will still remain the same. Well, my drawing is not that great, but I hope you understand the logic. So this frequency will still remain the same as this frequency, but just that the amplitude got varied. And this is known as an amplitude modulated wave. So what is this? This is amplitude modulated wave. Right? So now this wave is a high frequency wave. And what was our aim? Our aim was to convert this low frequency wave into a high frequency wave. And we did that. Right? So this is how amplitude modulation takes place. So let us have a look at a broader picture. So here you can see, what is this? This is high frequency wave. So that means this is the carrier wave. So how do we denote the carrier wave? The carrier wave is denoted by C, which is a function of T. This is how we denote the carrier wave. What is this wave? This is the low frequency message signal wave. So we denote it as m as a function of t, because everything is a time varying function, right? And this is my amplitude modulated wave. So if you see, the amplitude of the carrier wave varied, but the frequency still remains the same. So how do we denote this? We denote this as it is still the carrier wave, right? So this will still remain c as a function of t, but its amplitude got varied as per the message signal. So we denote it as CMT. So that is the amplitude modulated wave. Right? So the concept of amplitude modulation is clear? Okay. Now let us look at frequency modulation. How frequency modulation happens. So here also we will follow the same process. So for this also we need a carrier wave. So how will the carrier wave look like? It will be a high frequency wave. So somewhat like this. So this is a carrier wave. Now I also need a message signal. So what kind of message signal do we have? Somewhat like this. Now in this case it is frequency modulation, right? So what will happen? The frequency of the carrier wave will get modified. So that means the amplitude of the carrier wave will remain the same, right? Now let us see how this change happens. So now the amplitude is going to remain the same. So this is the amplitude, right? So here let us suppose if I draw the amplitude. So now the amplitude will remain the same, but the frequency will vary. So this amplitude will still remain AC. This will remain as minus AC. Now frequency means, what is high frequency? When we say high frequency, they are very close. When we say low frequency, they are far apart. That is how we understand whether the frequency is high or low, right? So in this case, whenever this high comes, so the frequency changes. So whenever this high area comes, these waves come very close to each other. Again after that, they become normal. Again when this low portion comes, they go wide away from each other. Again when high comes, they come very close to each other. So what do you see? Sometimes they are too close, sometimes they are too far. Again, sometimes they are too close. Again, a time will come when they'll be too far. So that means the frequency is changing, right? And how is the frequency changing? As per the message signal. So whenever the message signal is at a higher amplitude, the frequency will change. Again, when the message signal is at a lower amplitude, the frequency will change, right? So the frequency of the carrier wave is changing, and it is changing as per the message signal. So this is frequency modulation. So if you look at this picture here, again you have the carrier wave. This is the message signal, and here you can see the frequency is getting varied. Whenever there is a high, they are coming close together, that is the frequency is high. Whenever there is a low, the frequency is low. They are far apart, right? So the frequency is getting modulated. Correct? Okay. Now, I also told you how do we denote or how do we describe a sinusoidal wave. Now, if I ask you to describe this wave, that is the carrier wave, how will you describe it? We can write it as Ct is equal to A, where A is amplitude. So, amplitude of the carrier wave is AC, sine omega t. Similarly, you can denote a message signal as AM sine omega t. Now, what about the modulated wave? So that also, we will also look at the mathematical aspect of amplitude modulation in one of our next slides. So for now, just understand it graphically how different types of modulation happens. So on a similar ground, we can talk about phase modulation as well. So here again, you have this high frequency carrier wave and this low frequency message signal. In this case, what happens is, even though the result looks very similar to frequency modulation, but if you look at it, it is not the same. Phase modulation. How do you understand if there is a phase modulation? Let us suppose if this is one wave. Now, if there is another wave which is like this, we say that they are in the same phase. But if there is another wave which is like this, we say they are not in phase. Or even if we have something like this, we say they are not in phase. right? So the same thing happens here. Here if you see, here you have a high, here you have a low. But when you see this point, here you have a high, but here you will have a low. So basically this wave and this wave, even though they are same in their amplitude, but their phase has changed. Right? So once the phase changes, that means even though the carrier wave goes like this, the phase modulated wave might go somewhat like this, like this. So it will not have any phase relation. It will not be in phase with the carrier wave. Right? So the carrier wave changes its phase after being phase modulated by the message signal. Clear? Okay. So these were the types of modulation. So if you look the broader picture, you can see it here. So here we have shown all the three types of modulation: amplitude modulation, frequency modulation, as well as phase modulation. Thank you. Please visit www.examfear.com to watch more videos, attempt free online test, get free study material, find tutors and mentors. Thank you once again.